this wonderful thing with radius 1. And then we did some cosine rule and sine rule of this angle here. And we looked, if we used, not cosine rules, if we used the cosine ratio, and we had this as x, we said, cosine theta will be the adjacent side over the hypotenuse. We looked at that, so that's x over 1, which means that this length was just x, or was just cosine theta, sorry, not x. They're the interchangeable. And then we did the same thing for sine theta. We went, opposite. So let's call this y, opposite over hypotenuse. And we had sine theta to be y then, because anything over 1. Okay. And then to further that then, if you wanted to take this triangle and because it is a right angle triangle, although unmarked, now marked, we could use Pythagoras' theorem on it, which states that the two short sides squared should equal the long side squared. Yep. And that leads us to the Pythagorean identity, which is cosine squared theta plus sine squared theta is just 1.
But how?
Good question. So if I have a right angle triangle of any sort, if that's 13, 12, and 5, 5 squared plus 12 squared is equal to 13 squared. And the same thing, we got a right angle triangle here. This side squared plus this side squared must equal that side squared for all values of sine and cosine. Yes, it is very interesting. And this can be rearranged. So this might help us solve a question like is on the other board now. If sine theta is 3 over 4, negative 3 over 4, and we got a little precondition here. It's between something and something. Find cosine and tan. Okay, so I want to do this. There's a couple of ways I can do this. I'm going to do this, well, using the Pythagorean identity first. That's exactly what it's telling us, yeah. So this is my first bit of translation. Yeah, so what quadrant is that in? Well, you know that pi is all the way around to here, 180 degrees. So, and this is then 3 right angles in a row, so that's 270. So it sits between here, so it's in this quadrant, which tells us a couple of things about the signs of cosine theta and tan theta in this quadrant. I know that cosine is going to be negative, yes, because the x value in this quadrant, and tan will be positive. So that's, my answers definitely should be positive for tan and negative for cosine. But I don't know what cosine and tan are. There's 2 methods of doing this. Using the Pythagorean identity, this I can use, which suggests that cosine theta squared plus sine squared theta. Now sine theta is minus 3/4. Another thing to remember here, sine squared theta is the same as sine theta squared. Just don't get confused with those. So as you did in the starter. So sine theta then is minus 3/4 squared is equal to 1. And I should be able to get what cosine is from this. So cosine squared theta is equal to 1. Take away this. I think it's going to be positive. So this is 1 minus 9 over 16. So cosine squared theta is 7 over 16. And the square root of that will be root 7 over 4. Yeah. Now, it would be plus minus, but we already have an idea what it should be in that, which one it is plus and which one is negative. It should be negative, because we said it over here. Cosine theta is going to be negative. Now, what is tan theta going to be? Sine over cos. So sine is negative 3/4. Cosine is root 7 over 4. The 4s will cancel as usual, so we get negative 3 over root 7.
But wouldn't it be positive?
Why?
No?
Very well spotted.
Because
It's impossible. It's impossible. Yeah, it's impossible. Yeah, so sine, cosine I put in as positive. I should have put it in as negative because it was in the third quadrant. It's the same thing as that, yeah.
Is this possible to do by just drawing the triangle?
Yeah, absolutely. This was the second way I was going to do. You do not need the Pythagorean identity. One way, and the way I usually actually do it, is use every right angle triangle will have the same ratio that has this angle in it. So if I just say I just draw a right angle triangle, I can get the cosine ratio from it too. Sine is opposite over hypotenuse, which means if I just do Pythagoras' theorem, I would get this side to be root 7. And I wouldn't need to do, I can just read sine, cos, and tan off this right angle triangle, which is the second method to do it. Okay, I will do the other one, and then I'll let you guys do some work. Lexi needs a cup of coffee, I think. All right. The second example here, tan theta is minus 2. What quadrant it's in? It's pi over 2 up to, not including 2 pi. What quadrant is that?
So 360 the
So which quadrant?
cos. Between cos and alpha.
This one, fourth? Fourth quadrant, yep. Fourth quadrant, that's in. So 270 to 360. Find sine theta and cosine theta. For this one, I'm going to just draw a right angle triangle. I think it's easier. I know if this was theta, what is the opposite side?
-2.
You can just say 2. Because this depends on what quadrant it's in. You can just, the right angle triangle will have a length of 2. So we can figure out the signs by the quadrant in a minute. So signs don't really matter for distances. So 2 and the adjacent would be 1. Are we happy with that? 2 over 1. What's this side going to be? Fast maths.
2 squared plus 1 squared, 5. Root 5.
Yeah, we got there. Root 5. Okay. So root 5 is here. Now I need to figure out what sine and cosine is. Or yes, sine, then. Now I said, because it's a distance, it's just, we put in 2 and then we figure out the signs afterwards.
Okay.
So sine theta is going to be 2 over root 5. And cosine theta, I haven't actually figured out the positive or negative yet. And cosine is going to be 1 over root 5. Now I talk about, right, in this quadrant, sine is going to be what? What's the y value? It's definitely a negative y value. So sine is negative. Cosine, positive. So that's fine. I'm done. Look at that. Great stuff. Yep. Okay, I'll let you do the homework. Yeah. Yeah. Why not?
You know what's actually kind of ironic?
Well,
Yesterday
ironic?
I